been a while since I introduced synthetic division, and I only went over one example in the review last week. I'll go through that again with our practice exam example here. Now, to use synthetic division to determine whether some number is a zero of a polynomial function or not, we first write that number in a little bracket like we have here, and then to the right place the coefficients of the polynomial we're testing it in. So the leading coefficient is 2, that's here. The next coefficient is -1, that's here. And there's no x squared term, it's missing, and so we need a 0 as a placeholder for it. Don't overlook that. The next coefficient is 16, and finally the last is -8. So we place those on a line, leave a space to write another set of numbers, and then draw a straight line here. And our first step is to bring the first entry to the right of the one we're testing all the way down to the bottom line, below the summation line here. Next, we multiply the number we're testing times that first entry on the bottom line, and then put it above the summation line in the next column below the next coefficient in line. Then we add that column and put the result on the bottom line below this summation line. Next, we multiply the number we're testing by that new bottom line number and place it below the next empty place on the line above this summation line. So -2 times -5 is 10, and then we add that column and place the result at the bottom. So 0 plus 10 is 10. We continue this pattern by multiplying -2 times 10, which gives us -20. We place that here below the 16, and then we add that column. -20 plus 16 is -4, and then we finally multiply -2 times -4 to give a +8, and we add the -8 and the 8, and we get a 0. If we get a 0 down here in this last entry, then yes, -2 is a 0 of the polynomial function. Now let's take a look at the first matching question. Matching polynomials and or rational functions. Number 12 featured a polynomial, and we see that the first thing we're asked for is the zeros and multiplicities, and we see that if we substitute a -2 here, then -2 plus 2 is 0, and 0 here in this factor times any of this, no matter what it is 0. 0 times 0 is anything, so that makes the function value, which is a y value, 0. What is the multiplicity? Well, we look at the exponent here that factor is raised to. It's a 1. We don't write that 1. It's an invisible 1, but that gives it a multiplicity of 1. This factor is not factorable, it's prime, and so no real numbers as zeros will come out of that. The only way to, rather the zeros of this factor will be complex numbers, and we cannot graph complex numbers in the real plane, which is the plane that we always use. Now the other 0 is found here. If we place 0 here for x, then 0 squared is 0 times -1/2 is 0, and so 0 times anything is 0. That makes the function value 0, and its multiplicity is 2 because this x is raised to the second power. So we have zeros at -2 with multiplicity of 1, and at 0 with multiplicity of 0. To find the y-intercept, we look at the end here of the factored or of the expanded form of this function, and there is nothing there. If we placed a 0 here for this x and a 0 here for this x, both of these terms would be 0, making the function value 0. So the function has a y-intercept at y equals 0. Now, is the degree of the function even or odd? Well, to find that out, we look at the highest degree or leading term. It's 5, and 5 is an odd number, so put an X or a check in this box to indicate that the degree is odd. Finally, its leading coefficient is either positive or negative, and the highest powered term in the polynomial is the leading term, and its coefficient is the number in front, and that number is negative 1/2, so the leading coefficient is negative. Now, what graph would this match? Well, to find that out, we take a look at the graphs here, and we're looking for a graph that has a 0. It crosses the x-axis at -2 and 0. So which of these does? Well, graph A does. B doesn't. It has more zeros than that. C doesn't. It has 4. D does. D crosses the graph at -2 and 0. So we have as choices A and D so far. E has more zeros and F has more zeros. So now we look at A and D to decide which will be the matching graph. Well, if we go back to the function, we can see excuse me, that the degree is odd, the leading coefficient is negative. Now, when the degree is odd, the function will point down on one end and up on the other. But when that leading coefficient is negative, it's going to point up on the left and down on the right. And so that tells us that the graph that matches this function is graph D, and I've indicated that here.